Hi everybody. We are the engine testbed development project. I'm the team lead, Kay Leong, and this is Danny Lopez and Christopher Farrow. We had a fourth member in the first two quarters, but due to scheduling conflicts, he wasn't able to join us for the last quarter. So as a starting background, this project was developed and supported by the Advanced Power and Energy Program. It was initially, the initial concept came from a previous project on a natural gas running microturbine. When they did their performance results and emissions testing, they found that there were PM 2.5 emissions, and so they decided to extrapolate and wanted to know some of the effects of a natural gas reciprocating engine for all the different stationary power applications that it implies. So for us, the end purpose and goals were to produce a reciprocating engine testbed that operates on conventional and alternative gaseous fuels, to obtain a further understanding of pollutant formation mechanisms. We want to determine the theoretical values for efficiency, optimal flow, and predicted emissions compositions for comparisons to the base tests, and also conduct performance testing and mapping for the functioning testbed. And lastly, will be to establish a user's manual and data compilation for future researchers. And overall, we hope that these future researchers, future project management will go through, do some testing, find out a little bit more about PM 2.5 results from this. And then next one was the expectations. When you're in these projects, you're going to realize there's going to have to be a lot of contingency plans. Nothing ever goes to plan. You're going to start out with your project goals. You're going to run into obstacles and realize how it has to change. On the bottom, here's our initial fall quarter timeline that set out our goals for each quarter in the future. Naturally, didn't exactly happen. Some examples of the evolution of our project goals. We initially thought that for this project we would purchase a natural gas reciprocating engine and generator, and then have to learn how to fit those two together and then conduct tests, but instead we were donated a Generac DG50 set that we had to diagnose and repair. All we were told is the engine doesn't work. Further past that, we wanted to design testing parameters for various fuels, but it became a focus of performance mapping just for the natural gas. And then lastly, we want to obtain emissions results, including PM 2.5, but PM 2.5 testing is actually very complex and takes a long time, and we weren't able to get to that. So moving forward, handing this off to Danny.
So as for organization, since we were a very small group, it was pretty easy to be organized. The max number of people that were supposed to be in this group was 5, but we actually had 4, and then later became 3 because our foreign student from Sweden had to move back or take other classes. And as for our hierarchy, since we're a small group, it was just project leader and just the rest of us. And Katie would share tasks with us along with having to communicate with the advisors and also with Terry. Each unit is 4 hours a week, so we had to make sure that every time we met those hours, as long as it didn't conflict with our classes. And we also met once a week with our advisors to meet up and speak about our tasks and what we had finished, so that way the next meeting we would know what we have to do. Also, for organizing, we use Google Drive and GroupMe a lot. GroupMe is usually used for communications with time, and Google Drive was used a lot to organize our documents into folders, so that way we would all know everything for the project. As for strategies, a great strategy, as I said before, was using Google Drive. We would have a folder for each quarter, so that way we can visually see our progress. And we would also have a document called the Project Meetings document, which helped a lot because during the meeting we would type on there what our feedback was from the advisors, and we would also write our tasks. And those tasks would also be put on a board, that way we can see what needed to be done, what was being done, and what was finished. As for assigning tasks, that was actually nice in this small group because we could manage our tasks to the things we liked. For example, Katie liked calculations, and since she's good at it, she would get those kinds of tasks. I like design a lot, so I would design the Venturi that we used, and I also would like to work on the posters and handouts. Chris didn't really have a preference, but that's a good thing. He would do whatever job we needed to get done. And also another good strategy for purchasing is to look around local stores because sometimes it's inexpensive there rather than buying it from a company. And also to use the resources here on campus. For example, we use the 3D printing lab at Rapid Tech, and that saved us a lot of money. Instead of buying the Venturi from a company as a custom made, we just made it ourselves. On to Chris.
Okay, so obviously in every project you're going to have some room for improvement. The first improvement we would have for future projects, or advice to projects furthering on, is utilizing more external resources. So toward the end of this quarter, we designed a Venturi meter. Danny designed a Venturi meter. We used Rapid Tech on campus, 3D printing lab, to actually print that out. Using resources like that is actually very, very beneficial for projects like these, because then you're not only integrating them into what you're doing, but you're also maybe getting contacts with different people. So if you need something in the future, maybe they'll help you out, or you get contact with certain corporations that are near the area that help maybe they can help fund your project. Things like that. Big contacts, which is nice. Other improvements, time allotment. Since we only had 3 or 4 people max working on this group, it would kind of be difficult in the beginning because we'd all be outside working on the engine, and then nobody would be inside working on the office work. So it would kind of just be like a pick and choose between everybody's either working in the office or everybody's either working outside. Didn't really have 2 people doing things at once. But over time, we learned how to balance that. Maybe only send 1 person outside, 2 people working inside, or vice versa. So over time, we got better at that, but the beginning was pretty one-sided. Third thing, preparedness. I'd say when you're going into a project, if there are any juniors in here, you should probably go in with some sort of idea what's going on. Otherwise, you're just going to be learning on the fly, and you're going to be a step behind instead of a step ahead. So in choosing a future group or choosing a future project, you should probably go into that with some sort of knowledge beforehand. Like if you're into 3D printing, if you're into engines, if you're into SolidWorks, maybe you can find a project that works for you. Then independent action. We didn't really have much time to do this, but working outside on your free time for the project itself. Next slide. So major obstacles. The first one, as was mentioned before, that took pretty much all fall quarter was the engine operation and maintenance. So we were granted this engine, but all we were told is that it doesn't work, go and find something, what's wrong with it. So we had to do that for the entire quarter, find out what was wrong with it, try and fix it before we could even do anything else with the engine. So that was a pretty major obstacle. The next one, unforeseen complications. This happens to every group. We have things where we had our engine outside once and it was raining so heavily, something like we had a tarp, and there were 100 gallons of water in the tarp. So we had to put a hole in it and it would drain into this huge bucket. The draining process took alone an hour and a half or 2 hours of time that we could have been spent working on the engine. So little things like that, you can't really predict that, but they can sometimes have a major impact on what's going to happen in the project. Third thing, research. When you're trying to search the internet or find, call different people, maybe they won't call you back, or what do you do in that situation? It happens to all of us. So you just gotta keep digging. You gotta keep digging. So you're trying to find. Oh, I'm looking for this particular manual. I'm gonna keep trying to find it. But that takes time. Lots of time. You could be spent doing other things. Maybe if you had more people, you could have someone be the call guy, trying to call these different people. But obviously we didn't have that, so we had to make do with what we had. The last 2 parts delivery and menial tasks. The menial task, unfortunately, we had to do because if we were a small group, we couldn't just assign somebody to do that. Things like calling people and researching. We could have spent designing things or working on the engine, but instead we had to do this, so more time wasted. And then parts delivery. This is if you're ordering major parts, so maybe it would take months or weeks to come. That's time that you're waiting for the part. I can't do anything without this part, but you can't rush the manufacturer because they're the one making it for you. So that's another obstacle we have to worry about. Next slide. Okay, and then learning experience. So me, Ivan, who he's not here, and Danny, we had little to no experience going into the project with working on an engine generator or test bed set. Katie had worked with her dad on car engines before, but that was about it. We always didn't really have too much experience familiar with it. But after this whole experience, I could say I've gotten a lot of experience with looking at engines, seeing maybe what's wrong with them, and what's wrong with them, how to fix it. It's a pretty good experience in terms of also as well as problem assessment. If something's going wrong, for example, we had a distributor that wasn't working, the fan sheave or fan belt wasn't working, replace that. The battery had completely died, or replace that. So different things that you can just look at the problem, assess it, what do you have to do, and then move forward. Learning experience for Danny, a design of a Venturi flow meter, which she did, you see the picture here, using SolidWorks. It was very crucial and also in terms of engineering analysis, because you have to crunch the numbers first before you design something, because you don't want to design a faulty product. Documentation and planning, that was primarily Katie, learning from a managerial perspective. And then obviously, team effort, what everybody puts in is what you get out.
So throughout the project, you will be working with your advisor and sometimes a professional engineer. And whatever you learn, you should take on into your future career. So for example, the design process is a very good thing to take on to the future career. Those of you in 106 projects already know. So knowing how to brainstorm and keep all your designs and redesigns organized is a very good thing to know. Maybe using SolidWorks is a good way to present your work to your boss. Also, documentation for your tasks and goals is also something to carry on. A Gantt chart, for example, is very professional. Of course, you will learn public speaking, especially during the design reviews, because you will be talking to strangers and to professors. So you will be transitioning between technical speaking and speaking to a non-engineering audience. Also, I failed to mention that everything you learn should be put into your resume, because these are things that recruiters will see. You should also include reports and projects into your LinkedIn, so that way recruiters can see those as well. So for helpful tips, I would say, tips on choosing a project, I would say look at the list first, because you'll be surprised at the variety of projects. The list will also show you how many units you could take into the project. You're going to have to email a professor for the code in order to enroll. And also you should see the size of the group. You want to see whether you'd be comfortable in a big group or a small group, or even if you're willing to take on a project leader position. Also, once you've chosen your project, you should make sure to be responsible and to do whatever responsibilities are given to you, you should be done so you don't fall behind with your goals. Ultimately, this is not just a technical elective or just for senior design projects. It should also be an experience.
And then lastly, some just supporting statements in general. You want to have fun with your project. If it's not something you're interested in, you're not as likely to put as much effort into it. And by that following statement, whatever you put into it is what you're going to get out of it. This senior design project is geared as a learning experience, something for you to take more than just the base knowledge that you've been given over the last 3 years previous. It's supposed to help you, gear you towards a career in the future. Definitely don't be afraid to ask for help and ask a lot of questions. Your advisors are there for you. Terry has done a great job for us this year in helping lead us. And make sure to do some independent work, do independent research, attempt different solutions, so that way you can gather constructive criticism. And then just, again, have fun with it. It's out there for you as a resource. Take advantage. Thank you.